Zooming back out to something that's a bit more accessible if you're less technical, video processing is something we've been building on top of the image processing for a while. The most exciting thing here is I'm doing slightly backwards because video stabilization is kind of very accessible thing to look at. Let's run this first of all, and then I'll explain what happened. But it's actually a special case of a more general and more useful underlying feature that we've added, which is feature tracking. And the idea is that we've got, I'll show it to you in a moment when it's finished computing, a handheld video here that, like a lot of handheld videos, is a little bit shaky. So in a moment, it will have hopefully computed that. And now just processing the final video. And we can show the before and after. So the before here, very bouncy, shaky cam action. What this video stabilization has to do is to lock onto something that it thinks is representative of the frame, crop the frame slightly and adjust it so that those points remain stationary. And then after stabilization, you see all of that vertical wobble has been removed and we've got a much smoother video. But I think actually the underlying mechanism is more important, and that comes in a much more generalized feature tracking function. And I'm going to just grab one of the frames of video here and start this processing. I picked some arbitrary point here. It's like, what if we didn't care about watching the video? We actually care about what happens to something in the video. So in this case, maybe I want to, I'm choosing a flight path for a drone, and I want to keep focused on that space between the trees. So I've picked it here just by coordinate value. But I want to track how that moves. Similar problems would be, well, what if I'm doing ecology and I want to track the flight paths of 100 birds in a video? Then I want to have 100 start points, and I want to see how those points move independent of each other through the frame. So anything where you're analyzing objects within the video, security being another good example. Here's a person of interest in the crowd. Where did they go when we handed them off from one camera to another? Can we track them from frame to frame? So here you'll see my purple dot here has tracked the white space as best it can figure. Even though the shape of the space has changed, it's doing its job to track that. And we can track an arbitrary number of these from start points. Previously, we had image feature tracking only for things that had semantic meaning in the image. So you could say track things that is a car or thing that is a person. Now, anything that you can put a coordinate start point on, you can track that texture, that group of pixels effectively through the image, and track when they enter the image, when they leave the image, where they went, things like that, with any number of them simultaneously through the video. So anything with flows or movements that you need to analyze within video content, feature tracking is quite powerful. I think we're almost at the end of this next one. Wolf language aims to be a single joined up thing, not a bunch of random libraries that you have to write glue for. So we are finally filling out the last of the operations that work on images, like things like mean filter, that now if you say mean filter of a video, it will just do the right thing across the whole video. You don't have to write code yourself to map the mean filter command through each of the images on an image extraction of the video. So it's just proper joining up.